Hello, good morning class. Okay, so we continue, okay, our discussion for paper 1, right? So I think we stop until here, right? Wait, wait, let me open. Okay. Okay, so number 10, right? Okay, which of the following phenomena experiences forces in equilibrium? Okay, so if an object is in equilibrium, so there must be in the two state of motion. Okay, so if it's moved, it move in uniform velocity or constant velocity or in a stationary. Okay, so number 10, the answer should be C. Okay, so number 10, the answer should be C. Right. So this is the state, okay, when the object in a forces in equilibrium. Okay, so the resultant force acting on it is 0. So the object will either be at rest or is move with constant velocity. Okay, so let's say for this, we do a little revision. Okay, so the question asks you to label the forces acted on the object. Okay, so if the object, this is let's say a box, okay, on the table, so there are two forces acting on it. So the upward force is called as a normal force, okay, and downward force is called as the weight. Okay, and for the car, okay, so the first one also must have a normal force, okay, and this one is the weight, okay, and then it's the forward thrust, and this one is the frictional force, okay, or air friction. Okay, for let's say this ship, okay, the ship in this on the sea water, okay, so the upward force is called as a Bouillon Force, or we call it as the upthrust force also can, and the downward force is called as a weight. Okay, and this one, the girl in the lift, okay, the elevator, okay, so the downward force is called as the weight, the upward force is called as a normal force. Okay, and then this one for the hot balloon, so the downward force is called as the weight, okay, and then this one, okay, the upward force is called as a Bouillon force. Okay, and the resultant force, so what's the meaning of the resultant force? A single force that represents the combined effect of two or more forces in magnitude and direction. So what does it mean? Okay, so let's say, okay, so let's say I have a box here, okay, and then, okay, there are two-person, okay, so let's say this one push to the right 5 Newton, okay, and then this one push it to the left, okay, 3 Newton, okay, so you already know the net force is 5 minus 3, right, so 2 Newton, so the 2 Newton is a resultant force, okay, so the single force that represents the combined effect of the two or more forces in magnitude and direction, so two forces we combine it, okay, to produce a single force. So but this one, okay, because it's a different direction, so we minus it, 5 minus 3, so you got 2, so the 2 is a resultant force. Okay, all right, so let's move to another question. Okay, so diagram 7, okay, shows a spring of length 20 cm is compressed, okay, to a length of 10 cm when a load of 12 kg is put on top of it. So when the load M is put on top of it, the spring compressed to a length of 15 cm. Okay, so what is the value of M? Okay, you can use two way, whether you want to use the ratio, okay, like 12 kg, if you put the 12 kg, it will compress to 10 cm, and then what if I put what is the M if the compress is 5 cm, compression is 5 cm. You can use that method also, or you can use the formula. So F, okay, F is equals to Kx, right? Okay, and this one is actually we want to find the K first, okay, the spring constant. So the F here, so we know that you put the 12 kg, so means the force is 120 Newton, right? Because change kg to Newton multiply by 10, so 120. And then the K, you need to find first. Okay, and then the X, okay, so when you put the original length is 20 cm. Okay, and then you put the 12 kg, it will compress to 10 cm. So means the compression is 10 cm. So 0.1. Okay, and then you find K. K is 120 divided by 0.1. So you got 1200. So this is the spring constant. Okay, find the spring constant first. Okay, and then the next step, okay, you still use the same formula. F is equals to Kx. Okay, right. So now you can find the force. Okay, so now you can find the force. Okay, then if you want to find the mass, you just divide by 10 later. So the force here you need to find. The K is 1200. Okay, and then it's already said, okay, when you put the load M, so the spring is compressed to 15 cm. So mean the compression is 20 minus 15. So it's 0.05. Okay. Then if you multiply, so you got here, I think 60 Newton. So actually the force of M is 50 Newton. But you can see here, right, the answer is in kg. So how you want to change to back to kg? So you just divide back by 10. Okay, so you got 6 kg. Okay, so the answer is B, boy. Okay, so I use this method to use a formula. Okay, or you can use the ratio also can. Right. Okay, so move to the next question. Wait. Okay, so video rater revision. So actually this one, the question before, they use the Hooke's law, right? So what does Hooke's law say? Okay, so the extension of spring is directly proportional to the applied force, okay, provided the elastic limit is not exceeded. Okay, so F is equals to Kx, right? So F is the force given to the spring, X is the extension. When you have to remember, the extension should be in meter. Okay, change to meter. If not, you cannot use Newton as the unit, as the unit. And K is the force constant of the spring. Okay, so and the force constant is actually also represent the stiffness of the spring. Okay, alright. So let's say this is the graph. So directly proportional. So must pass through the 0, 0, right? Coordinate. So relationship between F and X, F is directly proportional. So the gradient of the graph represent the force constant. Okay, and then the area under the graph, okay, the area under the graph here, okay, is actually equals to the elastic potential energy. Or you can use the formula also, half Fx or half Kx square. So let's say this is, if you replace F with Kx, so you got half Kx square. So you can use both equations. It depends what's the info given by the question. If the question give you the force and the extension, use this one. If the question give you the spring constant and the extension of the compression, use this one. Okay, so just remember the gradient of the graph represent the spring constant, the stiffness of the spring, and the area under the graph is actually represent the elastic potential energy. Okay. Alright, so elastic limit of a spring. Okay, so what is the elastic limit? So the maximum force that can be applied to a spring such that the spring will be able to restore to its original length when the force is removed. Okay, so if the force stretches a spring beyond its elastic limit, the spring cannot return to its original length. So even the force no longer acts on it. So the Hooke's law is not obeyed anymore. Okay, so this is the elastic limit. So starting from this point, okay, the spring cannot go back to the original position. Okay, so if you put more load, it will keep extend like that. Then even like when you move it, it will keep extend like that. It will not go back to the original position. So mean it's already exceed the elastic limit. Okay, and starting from this point until here, you cannot use the Hooke's law anymore. Okay, because it does not obey the Hooke's law. Okay, because the Hooke's law said it must be directly proportional to the extension of the spring. Okay, so this one is not directly proportional anymore. Alright. Okay, so the factors that affect elasticity. So there are 4 factors. Okay, so length. Okay, so the shorter the spring, this will be less elastic. It means it will be more stiffer. Okay, and then longer spring is more elastic, so it's not stiffer. Okay, and diameter of spring, smaller diameter, it will be more stiffer. Okay, and more elastic. Okay, and the diameter of the spring, okay, smaller diameter is a less elastic, means it's a more stiffer. Okay, and the type of material is actually according to the to the type of spring. Okay, what type of material that we use to make the spring. Okay, but usually you only remember that these 3 factors. Okay, so the shorter the length, it will become more stiffer. The diameter of spring wire is thicker or larger diameter, it means it more stiffer. And also the diameter spring is very small, okay, means it's more stiffer. Okay. Alright, and then next one is the arrangement of the spring. Okay, so whether we put it in this series, okay, in series or in parallel. Okay, so in series, so let's say I put 20 Newton here. Okay, and let's say 20 Newton. Okay, let's say the 20 Newton. Okay, the extension of the spring will be 10 cm. Okay, let's say that's an example. Okay, so mean like every spring, the extension will be 10 cm, 10 cm. Okay. Okay, for this one, I use the same load 20 Newton, but since it's parallel, right? So 20 Newton, we already know 10 cm. Okay. So if you use in parallel, so you just divide by 2. So this one should be 5, this one should be 5. Okay. This one should be 5, this one should be 5. So if let's say I put 3 spring here, so what will happen? So the 10 cm will be divided by 3. So like 3.333 something. Okay. So let's say if I put another spring here, so mean there will be like 10 cm extension here. Okay. So this is actually the extension, not the total length of the spring. So if you want the total length of the spring, you have to plus with the original length of the spring before you put the load. This is the extension only. Okay. So if I put 4 spring, I put another one, we put in a parallel, so means you 10 you divide by 4. So like 2.5 for each spring. So mean now the extension will only 2.5. Okay. So this is the arrangement of the spring. Okay. Okay. So next one. Okay. So next question, diagram 2 below shows the velocity time graph of an object. So which of the following statements are true? Okay. So velocity against time. So what can you get info from this graph? Okay. So the first one you have to remember. Okay. The first one, the gradient, right? So the gradient represent the acceleration. Okay, the gradient represent acceleration. Okay, represent acceleration. Okay, and then another one is the area under the graph. Okay, so area under the graph, okay, is equals to the displacement. Okay, this is what you can get from the graph of velocity against time. Okay, so the question asks which of the following statement are true. So A is acceleration is increasing, B acceleration is decreasing, C acceleration is 0. So we already know if you want to find the acceleration, find the gradient. So how you can find the gradient? Like paper 3, you want to find a gradient, must have the triangle. So let's say if I draw a triangle here, okay. can see the size of the triangle, okay, it become smaller, right? So it becomes smaller. So means the gradient is decreasing. So when the gradient is decreasing, acceleration also is decreasing. So number 5, the answer is B boy. Okay, number 5, the answer is B boy. Alright, so we move to the next question. Wait. Okay. Alright, for number 4, okay, diagram 1 shows a strip of thicker tape which is attached to a moving trolley. So the trolley is moving with a, okay, so you can see here the length, okay, the length of each stick, okay, is same, right? It's constant. So means V is equals to S over T. Okay, so you can see the distance here is same. Means the velocity is also same. Okay, so constant velocity. Okay, constant velocity. Okay. Alright, next question. Diagram 2 shows a pattern of oil, alright, dripping at the constant rate from a moving car. Okay, which of the following describe the motion of the car? So actually car is different than the thicker tape. Okay, like if a thicker tape, the direction of motion is going to the right, right? So mean this stick will come first. This dot will come first. Okay, but let's say for the car, okay, this dot will come first. Okay, because the car move like this. So mean of course it will drip here first. Okay, alright. So for number 4, okay, which of the following describe the motion of the car? So starting from here. Okay, so you can see the distance is same, right? The distance of the dot between the two dots is same. So distance same means the velocity is same. So constant velocity. Then starting from this point, you can see the distance is decreasing. So means the velocity is decreasing. So velocity decreasing means deceleration. Okay, velocity decreasing means deceleration. So the answer should be D donkey. Okay, the answer should be D donkey. Alright, next slide. Okay, number 5. Okay, number 5, diagram 5. Diagram 3 shows 4 motion of graph P, Q, R, and S. So which of the graph for motion with constant velocity? Okay, so we do a little revision here. Okay, so I have graph. Okay, S displacement against time, velocity against time. Okay, for the displacement against time, the gradient is actually equals to the velocity, right? The gradient is equals to V. Okay, and for the velocity against time, so this is the only info that we can get from the displacement against time. But for the velocity against time, there are 2 info you can get. The first one, the gradient, we already discussed before. Okay, the gradient is A. Okay, acceleration. Area under the graph is displacement. Alright, S. Okay. Okay, so try to use this info to answer this question. Okay, for P, so this one is S over T. Okay, so you want the constant velocity here, right? So if I want to find the velocity, I need to find the gradient. So can I draw a triangle here? No. So means the gradient is 0. So the gradient 0 means the velocity is also 0. Okay. So P is wrong. Okay. Okay, for this one, if I draw a triangle, right? Triangle, you can see the size is same. Means the gradient is also same. So the gradient same means the velocity is also same. Means constant. So Q is correct. Okay, for R, okay, this one is easy. Velocity constant, so means this one is constant, right? Does not change. So Q and R. So the answer should be C. Okay. Right. We move to the next question. Okay. So diagram 4 shows a brick falls from high building. So which of the following quantities remains unchanged? Okay. The first one acceleration, B velocity, C kinetic energy, D is momentum. Okay, so when a brick falls from the high building, so usually it falls under the gravitational acceleration, which is always constant. Okay, so A is 10, right? A is 10. Okay, so this one, the answer is A. Okay, alright, so we move to the next question. Okay, diagram 3 shows a velocity time graph for motion of an object. Based on the graph, which of the following statement is true? Okay, so the car move with constant acceleration then stop. Okay, no. Okay, so we divide, right? We divide into two sections. Okay, A and B. Okay, A and B. So for this one, okay, constant velocity, no. Constant acceleration, okay, let's see. Okay, if I draw a triangle here, okay, and we already discussed before, the gradient is equals to the acceleration. So if I draw a triangle, the gradient is same. So means the acceleration must be also same. So acceleration same means constant acceleration. Okay, and then stop. Okay, so you can see for section B, the velocity is constant. Okay, it's constant. It's not changed. Okay, so me, but is it stop? No, it's not stop. Okay, it's constant acceleration, but then stop? No. Okay, and then for B, the car move with constant velocity. Is it constant velocity? No. And then stop? Also no. If stop, must be at the x-axis here. Okay, and then C, the car move with constant acceleration. Okay, correct. Then constant velocity. Okay, correct. So the answer should be C. Okay. Alright. Okay. So next question. Okay, next question. Diagram 2 shows the journey, okay, of a bus from a city A, okay, to reach D, city D. So what is the displacement of the bus? So what is the displacement? Displacement is the shortest distance, okay, with specific direction. So if I want to go from A to D, okay, so the shortest distance should be this way, right? Okay, and then next one, you draw a triangle. So this is 80, so this one also must be 80. Okay, but for this one, the height here, so 100 minus 40 is 60. And then you use the theorem Pythagoras, so this one should be 100. So the answer should be B, boy. Okay. Alright, next question. Okay, so diagram 2 shows a girl standing on the platform on a train station watching a train. So the train starts from rest and move with acceleration of 0.2. So the girl observed that the train takes 24 seconds to move faster. So what is the length of the train? Okay, so first you have to take out what is the info given in the question. Okay, so the info given, the train starts from rest, so U is 0. Okay, and acceleration is 0.2. Okay, and then the girl move, okay, observe that the train takes 24 seconds, so means T is 24. Okay, and ask you to find the length. So length is S, right? So S you need to find. Okay, so if you remember, right, the formula for the equation of motion, right, V square is equals to U square plus 2AS, is U, sorry, plus 2AS, okay, and then S is UT plus half AT square, okay. So which formula you think that you can use? So you can see from the info here, SUAT. So means you have to use this one, okay. So I erase it back. Okay. So S is equals to UT plus half AT squared. Right? So S you need to find the length of the train. U is 0. Okay, T is 24 plus half. A is 0.2 given the equations, and T square is 24 square. Okay, and then you just use your calculator. So you got your answer is B boy. Okay, just calculate using your calculator. You got the answer B boy. Alright, so we move to the next question. Okay, a lorry of mass 9,600 kg is moving with velocity of 0.025 km per second on the highway. Suddenly, it brakes and hit the road divider. Calculate the impulse of the lorry. So, what is the formula for impulse? Ft is equals to mv minus mu. Okay, so for this question, okay, you cannot use both formula. Only use whether on your left side or your right hand side. Okay, so you can see it give you the mass, right? The m, and it give you the v, right? So means you have to use this one. Okay, you have to use this one. Okay, so we use this one, mv minus mu. Okay, so mass is 9,600. Okay, V is 0.025. Okay, and then minus 9,600. So we assume, okay, suddenly it breaks and hit. Oh, okay, sorry. Sorry, the V is 0. Okay, the V is 0. Wait, I erase it first. I didn't notice it. Okay, MV minus MU, sorry. And then this one is 9,600. Okay, the V is 0. Okay, M is 9,600. Okay, and U is 0.025. Okay, because it said it suddenly it breaks, so means it's break, it will stop. So V is 0. Okay, and then we got negative, right? Negative 2,240, I think. Is it? 960 times 0.025. I'm sorry, 0.025. Okay, 0.025. Okay, yes, you got 240. Okay, so negative 240. So you change to the standard form. So you get 2.4 times 10 power of 2. So this one is actually, it just show the direction. Okay, it's not the value. The value is negative. Just to say the direction only. Okay. Okay, the next one. Okay, the next one. Okay, graph. Diagram 3 shows a displacement time graph for a lorry moving up a hill along a straight road. Okay, so which of the following graph represent the change of velocity of the lorry with time? Okay, so as you know, the displacement against time, the gradient is equals to velocity. So let's say if we draw for this part T1 first, okay, you can see the triangle become bigger. Right, so means the velocity is increasing. Okay, so the velocity is increasing. So for this one, no, should be increasing linearly like that. Okay, all right, and then for this one, if you draw a triangle, okay, the triangle will be the same. So means the velocity is constant. Okay, it's constant. All right, the velocity is constant. Okay, so for this one, you are both still correct. Okay, and then for this one, if you draw a triangle, the triangle become smaller, right? Become smaller. So when it becomes smaller, means the velocity is decreasing. Okay, so the velocity decreasing. So the answer should be C. Okay, you just draw a triangle and you see the size of the triangle. So if the size of the triangle increasing, means the gradient also increasing. So then the velocity of the acceleration is increasing too. It depends on the graph. Okay, what is the graph against what? Y against y. Actually, y against x. Okay, all right. The next one. Okay, for this one, okay, diagram 5 shows a flower pot. Okay, a flower pot of mass 2 kg hanging from a pole. Okay, so calculate the tension T of the string. Okay, for this one, you have to draw a triangle. Okay, so I draw the triangle here. Okay, right, this is T and this is also T. Okay, and then already give you the mass here. The mass is 2 kg. So the 2 kg means the weight is 20 Newton. So this is the W. Okay, alright, so you don't know the angle here, right? Okay, so let's say I draw like this. And this is 90 degrees, right? So this is 90 degrees. So this one should be 60. Okay, so this one should be 60. So mean this one also must be 60. Okay, then I draw. Okay, then I take out the half of the triangle. I draw again so you can see it clearly. So this is 60. Okay, this is T. And this is the weight. So the weight already changed like to 20 Newton, right? Okay, so the question want you to find the T. So this is 90 degrees. Okay, so this is called as a hypotenuse. Okay, and this one, the weight is called as a adjacent. Okay, so HA, so this one you should use cos, right? So cos 60. Okay, so the adjacent is 20. The hypotenuse is T. Okay, cos 60 is actually adjacent divided by hypotenuse. So catur, right? Okay, and then you find the T, you use a calculator. I think you got like 40, if I'm not mistaken. Okay, so 40 Newton, but you have to remember there are 2 T here. Okay, so mean you have to divide by 2. Okay, so 20 Newton. Okay, because the mass of the spring is actually, the weight of the spring is actually supported by the 2 tension here. So the one that you find, the T here is actually for the 2 tension here. So you only want to find 1, so you have to divide by 2. Okay, so the answer should be B, boy. Okay, next one. Okay, diagram 6 show the 3 forces of P, Q, and R. Okay, P, Q, and R. So acting on the 3 different objects on the acceleration produced. Okay, so which of the following statement shows the force? Okay, arrangement. Following statement shows the force arranged in ascending on the order of their magnitudes. Okay, for this one you have to use a formula, you can calculate one by one. Okay, so how you want to find the force when he given you the mass and the acceleration? So you should use F is equals to MA. Okay, and then the force you need to find, so you need to calculate one by one. So let's say for P is 4 times 2, right? So you got 8 here. Okay, and then for this one is also same, use it for this formula, 5 times 2, so you got 10 here. And this one 3 times 3, so you got 9 here. And then you just arrange, okay, ascending. So the first one should be P, R, and Q. So P, R, and Q, the answer should be B, boy. Okay. Alright, so next question. Okay. Oh, sorry. Sorry. Okay. Ali kicks, okay, a ball of mass 1.5 kg with a force of 50 Newton and the time of impact between his boat and the ball is 0.2 seconds. So what is the change of momentum of the ball? So actually what is the meaning of the change of momentum? Right? So the change of momentum is actually impulse. Right? The meaning of impulse is change of momentum. So actually this one you want to find impulse. Okay. So what is the formula for impulse? Ft is equals to mv minus mu. Like I said before, you cannot use both. Alright, you have to see what's the info given to you. So I giving you mass, he given you force, giving you m, he given you f, and he give you t. So mean this one you have to use f and t. So 50 times 0.2. So you got 10 Newton second. Okay, the answer should be A. Okay. Alright, so next question. Okay, Ahmad is walking up a stairs with 10 steps. So each step is 50 cm height. So calculate the gravitational potential energy gain if his weight is 550 Newton. Okay, so gravitational potential energy is, the formula is mgh. Okay, mgh. Okay, and the mg is actually is the weight, right? W is mg. Okay, so the question already give you the weight here. So 550. Okay, giving you the mg already. So you don't need to calculate this one. Okay, for the height, so it said that Ahmad is walking 10 steps. So each step is 50 cm. So 50 times 10. Okay, so 50 times 10. So you got 500 cm. Okay, and then you have to remember, okay, if we want to use this formula, the h must be in meter. So you just divide by 100. So you got 5 meter. So then just multiply by 5. Yeah. Okay, if not, you cannot use the unit joule here, right? The joule must be in meter. So 500, 550 times 5, you got like 2,750, I think. So number 7, the answer is B, boy. Okay. Alright, so next move to the next question. Okay. Alright. So the diagram shows a 2 kg object pulled upwards by a force of 30 Newton. I don't think pull upwards, this one downward, right? So pull downward by a force of 30 Newton. So calculate the acceleration of the object. Okay, so if you want to find the acceleration, right, the main thing you have to remember, you have to find the net force first. Okay, so let's say if they got the frictional force, so the force applied must be minus first with the frictional force to get the net force. So same like this one, okay, so this one is 30 Newton, and you know also, okay, there is a weight here, okay, so means there will be a downward force also. So you have to minus first, right? You have to minus first to find the net force. Okay, so F is equals to MA. Okay, so what is the net force here? 30 minus 20. So this one change to Newton first. So 30 minus 20, so the net force is 10 Newton. Okay, and then the mass, so because only using this, okay, load is 2 kg, so 2. So A you got like 5 ms negative 2. Okay, so the answer should be B, boy. Okay. Alright, so we move on to the next question. Okay, graph. Okay, diagram 2 shows a displacement time graph for a moving object. Okay, so which of the graph, okay, which is graph is correct to describe the motion in velocity time graph? So again, we know that the velocity is actually the gradient of the displacement against time. So for the T1 until T2, so can I draw a triangle here? Right, so I cannot draw a triangle here, so mean the gradient is 0. So here should be 0. Okay, so obviously you already know the answer is C, but we still, okay, sorry, we try to check first. Alright, for T2 and T3, if you draw a triangle, so the triangle should be same. So means the gradient also same. So the gradient is the same and the velocity is constant. Okay, correct? Okay, and then for this one, okay, you can draw the triangle. So you can see the triangle is same. Alright, so mean the gradient is same and then the velocity is constant. Okay, but okay, it must be in the negative value because mean is go back to its original position, means it's move in the opposite direction. So the velocity should be negative here. Okay, so the answer should be C. Okay, right, so let's move on to the next slide. Okay, so the diagram below shows a catapult that is aimed to a chicken. Okay, so a 5 Newton force is applied to the catapult to produce an extension of 10 cm in the elastic cord. So calculate the elastic potential energy stored in the elastic cord. So this one, I told you already, we can use the formula. Okay, E is equals to half Fx. Okay, so the force is 5 Newton. Okay, and then the X is the extension. So this one have to change to meter first. If not, you cannot use joule here. So you got the answer. I think for me, I got the answer is, wait. I got the answer is 0.25. Okay, but there's no answer here. Okay, 0.25 joule. Okay, 0.25 joule. So there's no answer here. Okay, no answer. Okay, so the answer is 0.25 joule. Okay, so let's move to another question. Okay, for this one, okay, which object has the largest kinetic energy? So this one you have to calculate one by one. So what's the formula for the kinetic energy? Is half mv square. Okay, half mv square. Okay, I just show one example. So let's say for A, okay, so the mass is 90 and the velocity is 20 square. Okay, so and then you use your calculator. So you got your answer is 18,000. Okay, 18,000. Okay, and then use the same formula to calculate A, B, C, and D. So I already calculate, so I got the answer is C. Okay, so the answer should be C. Okay, use the same and then choose which one is the largest. Okay, so next we move to the next question. Okay, so ticker tape, right? So diagram below show a tape charge which is produced by moving trolley. The frequency of the ticker tape is 50 Hz. Okay, and then each strips of ticker tape contains 5 ticks. Okay, so underline this one. Okay, 5 ticks. Okay, what is the trolley acceleration? So the formula for the acceleration is V minus U divided by T. Okay, so you have to find first the velocity, the final velocity, initial velocity, and the time. So let's say you find the velocity first. So find U first. So the initial should be this one, the first ticker tape here. So this is U and this one must be V. Okay, for U is S over T, the displacement. The displacement is actually the length of the ticker tape. So it's 4. Okay, and then the time. So how you want to find the time? Okay, so it said for you is already contain the each ticker tape contain 5 ticks, right? Okay, and then one tick is actually equals to 0.02. Okay, because normally in Malaysia, our frequency for electricity is 50 Hz. Okay, so in Malaysia we use the frequency of our electricity 50 Hz. So if you want to find, you also can use this one. Okay, 50, okay, 1 divided by T, and then T is 1 divided by 50, you still got 0.02. Okay, so one tick is 0.02. Okay, so if each strip contain 5, so means 5 times 0.02 here. Okay, so 4 divided by 0.1, you got 40. Okay, so U is 40. Alright, and then for V, right, V is the last ticker tape here. Okay, final here. So 24, still use same formula. 24 divided by 5 times 10 power of 0.02. So 24 divided by 0.1, so you got 250. Okay, how about the time here? Okay, so the time here, okay, we just need to jump the 1, 2, 3, 4, 5. So 5. 5 multiplied by, so each thicker tape, okay, is how many seconds? Is 0.02 times 5 tick. Okay, because each thicker tape contain 5 ticks and each tick is 0.02. So the length, the time taken for each tick, we just multiply here. So you got 0.5. Okay, so you got 0.5. Okay, 0.02. Alright, and then you just substitute in this formula. Okay, so 240 minus 40 divide by 0.5. Right? Then you just use calculator. So you got your answer D donkey. Okay, so number 54, the answer is D donkey. Okay. So let's say if you don't have enough time to like copy back, okay. I will put it in the YouTube. You can check there. Okay, all the answer. Okay, next one. Okay, so the next question. Okay. So diagram below show a box of mass 5 kg slide down a smooth curved ramp. So what is the speed of the box when we reach the bottom? Okay, so for this one, we use the principle conservation of energy. Okay, so we know here, we start from here. Okay, so start from here is the gravitational potential energy. So when it come down here, it will change to the kinetic energy. So we assume that the gravitational potential energy is equals to kinetic energy. Okay, so the formula for gravitational potential energy is mgh equals to half mv square. Okay, so you can find the speed here. Okay, because the kinetic energy, they got the velocity. Okay, inside the formula. So m is 5, g is 10, h is 20. Okay, and this one half m is 5, v square you want to find. Okay, then you just solve the equation here. So you got 20. So the answer is B. Okay, so the answer is B. Alright, let's move on to the next question. Alright, number 91. Diagram below show two spring hand on the retard stand with a load. So the original length of the spring is 20 cm. So if the load of is 50 gram added, the length of the spring is 30 cm. Calculate the length of the spring system if we add another identical spring in series. Okay, so in series. So mean you will put one more spring here. Alright, so the original length is 20. So when you put 50 gram, the length become 30 cm. So means the extension is 10 cm. Okay. So and then you put another spring. So means here, this one already know the length is 30 cm, right? And then you put here, okay, the same length in series. So this one should be 30 also. Correct? So the answer is 60. Okay. So C. Right? Okay. So next question. Okay, diagram below show extension of spring. So the extension of the spring can be increased by. Okay, so if you want to increase the extension means the spring is less stiff, correct? If you want to make your spring is the extension of spring decrease, mean you have to make your spring stiffer. Okay, so if you want to extend the spring, if you want to increase the extension of the spring, you have to use the spring that less stiffer. So we already learned that the factor that affecting the extension of the spring or the stiffness of the spring. Okay, so use a shorter spring. So shorter spring means your spring will become stiffer. So means the extension is not increased. Okay, will be decreased. Okay, use a thicker spring that is more actually they didn't give you. Okay, use a thicker spring. Okay, so thicker spring means the wire is become thicker, right? So when the wire is thicker, the extension of the spring will not decrease, right? And then for C, use a bigger diameter spring. So this one is actually will increase the extension of the spring. Okay, smaller diameter spring, it will be stiffer. Okay, that big diameter spring, it will be less stiffer. So the answer should be C. Okay. Alright, next question. Right, number 51. Okay, same still a spring question. So diagram below shows a graph of stretching force F against extension X of spring R and S. So both springs are made of same material and have the same thickness. Okay, so what you can get from the graph, okay, remember the first one is the spring constant, okay, and then second one is the elastic potential energy. So for this one, if you want to know whether it's stiff or not, so you have to know the gradient, okay. So if you compare R and S, okay, we can see R, the gradient is much higher. So mean R is stiffer than S, okay. So A is totally wrong. Spring S has smaller stiffer and smaller stiffness. Okay, the answer is A. Sorry, spring S has smaller stiffness than spring R. Okay, so number 51, the answer is A. Right. Okay, so next one. Okay. Oops. Okay, we go to the chapter 3. Okay. So diagram shows a manometer connected to a balloon. So what is the pressure PB inside the balloon? Okay, so this one, if you press the balloon here, okay, so of course the pressure here will be high. So we will push the mercury down, and so this one, the mercury will go up. So the H will be increased, right? So if you want to find the PB, means the atmospheric must add with the H rho G. Okay, so the answer should be C. Okay, PB is P ATM, P atmospheric, pressure of atmosphere plus H rho G. Okay, for the next one, so this is the revision. Okay, so this is the manometer. Okay, so if you want to measure the gas pressure, okay, so let's say you can see here, okay, the height of the mercury is same. So mean at this time the pressure of the gas is actually equals to the pressure of atmosphere. So here is actually they got the atmospheric pressure here. Okay, they got the atmospheric pressure here. Okay, this one also got atmospheric pressure. Okay, so mean at this time, okay, both pressure is same because you can see the length of the mercury is same. Okay, for this one, for this one you can see the gas is bigger than the atmospheric pressure. Why? So because if let's say you for the balloon before this, okay, the balloon you press, so the pressure is high. So when the pressure is higher, you push the pressure, we push the mercury, okay, and then this one will go up. So mean this one the pressure is higher than atmospheric pressure. So because it can push, okay, push the mercury for to go up. So mean it bigger than atmospheric pressure because the atmospheric pressure you should go down, right? So it can push it up means it bigger than atmospheric pressure. So if you want to add, so the P gas is actually is P ATM plus H rho G. Okay, P ATM means pressure, atmospheric pressure plus H rho G. Okay, for this one, you can see, okay, the atmospheric pressure is push the pressure of the gas here. So mean this time the atmospheric pressure is higher than the pressure of the gas. So how you want to find the P gas? So the PATM minus H rho G. Okay, minus H rho G. Okay, so that's how you got the reading for the pressure for the Yes, right? Okay, so let's move on to the next question. Okay, so diagram shows a tractor on a muddy ground. So why does the tractor has a big and wide tires? So of course to reduce the pressure, right? P is equals to F over A. So when the area is bigger, the pressure is lower. Okay, use the equation. Alright, the next one. Okay, so this is the revision. So define the pressure. So pressure is a force per unit area. Okay. And then the state for the formula. So P is equals to F over A. And then the unit must be in Pascal, or you don't want to put in Pascal, you can put NM negative 2 also. So the relationship, the pressure, okay, when the pressure increase, the area should be decreased. Okay. So the increasing the pressure by reducing the area. So this one already know the like the tractor, right, in the muddy ground. Okay, so for number 13. Okay, so this one we use the atmospheric, the one that we did the manometer one, okay, before this. Okay, so what is the water pressure at X? So for this one is actually the pressure for the water is higher than atmospheric pressure. So means you have to add, right? So 75 plus 3.8. So you got 78.8. Okay. So this one because the gas, sorry, the water pressure is higher than the atmospheric pressure. So you add the atmospheric pressure, okay, with the different length between the two sides of the mercury here. Okay, the difference of the length here. So 3.8, so you got 78.8. Okay, so this is the one that we already discussed before. Okay. Right, the next one. So diagram shows a part of hydraulic brake system of the car. So which of the following is not characteristic of the brake fluid? So the answer should be the low boiling point. Okay, low boiling point. Okay. So what is the question is actually involving the Pascal, right? Pascal principle. So we do a little revision about the Pascal. So what does the Pascal say? So it states that when pressure is applied to the aqueous liquid, the pressure will transmitted equally throughout the whole enclosed fluid. So actually what does it mean? The pressure must be same. Okay, the pressure must be same. So this is the experiment, okay, to verify the Pascal. So let's say you put the when the piston is pushed, okay, into the glass sphere. So you put the glass sphere inside the water, and then you push the piston. You can see the water, okay, the water spurts out, okay, in the same direction, okay, throughout all direction, okay. Okay, so this is to prove that the pressure is transmitted, okay, uniformly throughout the water. Okay, so this is the formula for Pascal. Okay, F1 over A1 equals to F2 over A2. You can use this one also, but usually we use this one. Okay, F1 A1 equals to F2 A2. Okay, we use normally this one. Okay, because we know that P1 is equals to P2, right? The pressure is same for both cross section. So we know P is equals to F over A, P is equals to F over A, so we just substitute it. Okay. Alright, let's move to the next question. Okay, so explain hydraulic system. So a small input F1 is applied to the small piston resulting in a large output. So this one is remember the equation, right? P is equals to F over E. Okay, so PA is equals to F, right? So let's say if you push a brake, right, for the car, you can see the area is just small. So why you put the area is small for the brake? So you only need a less input force. You don't need to push the brake so hard. Okay. So means because that one is so the input force should be lower. Okay, and then you can see at the second pistons, right? For the second piston, okay, or at the brake there, you can see the area is bigger. So when the area is bigger, the force also will be bigger. So mean the bigger force will be produced. So it will grip the tire, right? It will grip the tire and then the tire will not move. Okay, so you will stop. The car will stop. Okay, so that's the explanation. Okay, for connecting or what is the connection between the area and the force. But the pressure you must remember is always the same, right? Mm, okay. Okay, so for this one, when incompressible fluid is moved throughout the hydraulic system, the volume throughout with the input system move must be the same. Okay, so they say the volume here, when I push the piston here, okay, when I push, they say the volume here is 20 cm cube. Okay, then the volume here, okay, the volume of water also here will be increased, so also 20 cm cube. Okay, but the only thing is difference is the distance lah. Okay, with this one, let's say you so you can see here the distance is bigger, so this one is smaller. Okay, so the hydraulic system act as a force multiplier. So they multiply the input force by a certain factor to get a large output force. So force multiplier. So they say the area here is 1 to 5. Correct? So they say the ratio here is 1 to 5. So means they say if you give one force here, so there will be like 5 times of force produced compared to the F1. Okay, so they say 1/5. So mean they say I put here 10, so here should be 50 Newton produced. Okay, so that's why it calls a force multiplier. Okay. Okay, so the magnitude of the force at the large piston depend on the force F1 applied to the small piston. So the force produced here, it depend on the force at the F1 here. What is the value of F1 you applied here? And then also the ratio of the surface area. So this one I already discussed, right? So they say this is 1, this is 5. They say of course this one 10, this one should be 50 Newton. Okay, so it depends on the surface area and also the force given. Alright, the next one, the hydraulic system must not contain any air bubbles in any position on its hydraulic fluid system. So this will reduce the efficiency of the system as part of the applied force will be used to compress the air bubbles. So what does it mean? So why we use oil? Why you not use water? Okay, because water is easy to compress. So mean when easy to compress, so it will easy to form a bubble there. So we don't want a bubble. Why? Because we got a bubble here, right? Then the force we give, let's say I give 10 Newton here, right? So that 10 Newton will be used to compress the bubble here first. So it will be like a wasting, right? So that's why we don't use a water here, okay? And so that's the meaning. So it will be used up to compress and only like a few, okay, like then the force will be decreased, okay, when it comes to the output piston here. So that's why we use the that's why we use the oil, we don't use the water, okay? Alright, so the next one, okay, so see number 15, diagram shows a cross section of the iceberg, okay, floating. So I want you to underline the word floating. Floating on the surface of the sea. So which statement is true? So this one is actually the Archimedes, right? So anything that object that float, okay, usually there we have a Archimedes. Okay, Archimedes principle. So the Archimedes said the floating means when the object is floating, so we assume that the weight at that time is equals to the Bouillon Force. Okay, so means W is equals to FB. Okay, Bouillon Force. Right, so the answer should be A. Okay, number 15 is A. And weight of the seawater displaced is actually equals to weight of an object, right? So you already know the Archimedes. Okay, so let's see for the next slide, we do a little revision about the Archimedes. Okay. So applying the Archimedes principle. So what is the Bouillon force? So Bouillon force is the upward force. Okay, so upward force resulting from the object being wholly or partially, okay, immersed in the water, in the fluid. Okay, so Bouillon force make things seems to be lighter. Okay, so let's say I have a two measuring cylinder here. Okay, and then I put the stone. Okay, so let's say when I put it in the I okay, they say the weight is 25 Newton here, okay, on the air. So this is 25 Newton. Wait, can I drink water? Mm. Okay. So the weight of the object in air is 25 Newton. Okay. Then when I put it in the water, so then the reading is become 15 Newton. Right? So the weight on the object is an air is the actual weight. So actually the weight is 25 Newton, and then when you put in the water, then the 15 Newton here is called as a apparent weight. Okay. So you can see the weight is reduced, right? So the apparent weight loss. Okay. So where does the 10 Newton go? Okay, it turn to the Bouillon force. So actually the Bouillon force here is 10 Newton. 25 minus 15. Okay. So the apparent weight loss of the object is due to the Bouillon force. So when in water, the object experiences two force. Okay. The first one is the actual weight. Okay. W is going down. And the second one is the Bouillon force is going up. Okay. So the Bouillon force is equal to the apparent loss in weight. So the Bouillon force is 25 minus 15, so 10 Newton. So 10 Newton is the Bouillon force. So the object displaces a volume of water. So the bigger the volume of water object immersed, the bigger the volume of liquid displaced. Okay. So the volume of liquid displaced is actually equal to the volume of submerged part of the object. Okay. Next question, next one. Then state the Archimedes principle. So Archimedes principle state when an object, okay, immersed partially or fully in the object, okay, there will be an upward force, okay, acting on it that is called as the Bouillon force. And the Bouillon force is actually equals to the weight of the fluid displaced. Okay, so weight of the liquid displaced. Okay, so for the equation for Bouillon force, so they say it will ask you to find, okay, the value of the Bouillon force. Okay, you have to remember the Bouillon force is actually weight of the fluid displaced. Or you can use the formula rho Vg. Okay, rho is actually the density of the water. Okay, if you put the object in the water, so means the density of the water. V is actually the volume, okay, volume that submerged in the water. Okay, so actually this one, this is the V. Okay, it's not the volume of the object, okay, but it's actually the volume of the object that immerged, okay, that immersed in the fluid. Okay. And then, or you can use this one, Bouillon force is weight object in air minus weight in water. This one is if the question gives you diagram like this, diagram like this, then you can use this formula, number 3. Okay, just minus 25 minus 15, right? Okay, or let's say usually they will use formula lah for VG here. Okay. Okay, so Bouillon force. Okay, Bouillon force. If the Bouillon force is equal to weight, the object will float or stationary. And stationary. If the Bouillon force is bigger than weight, so means that object is floating. Is moved upward to the surface of the water. If the Bouillon force is, this one should be smaller, right? If the Bouillon force is smaller than weight, okay, the object is moving downward like that. Okay, going deeper into the water. Okay, so this is the Bouillon force, the connection between the Bouillon force and the flotation. Okay. Okay, number 16. Okay, so which diagram shows the correct water level, Okay, when the water flows steadily through the glass tube. Okay, so this one is actually we use the Bernoulli. Okay, so what's the Bernoulli shape? Bernoulli shape, when the velocity is high, okay, the pressure will be low. Okay, so let's see for this question. So here for this part, the velocity is low, right? Means the pressure will be high. So mean the water will rise up. Okay, so this is wrong for A. Okay, and then for B, okay, for this part, okay, for this part, you can see the tube is narrow, right? So means the velocity here is high. So means the pressure will be low. So the water will not rise up. So this one should be the lowest one. Okay, should be the lowest one. So this one is wrong. Okay, right. So this one should be the lowest one. Okay. So whether is C or D. Alright, and then the next one, since the water come from the high velocity place, right? So for this one, the velocity, okay, is lower. But this one is the lowest. Okay, this one is the lowest one. Okay, compared to this. So when the velocity is lower, the pressure is high, right? And then this one, the pressure will be highest one. Okay, so this one, it will rise up, okay, but not as much, okay, as this part, okay, because this one, the velocity is compared to this one, the velocity, this one is much lower. So mean the pressure here will be higher than this one. And this one, because it just come up from the high velocity, right? So this one, the velocity is lower, okay, the velocity is lower, but it's not as low as from this part. Okay, so it will be on the middle here. Okay, so the answer should be D donkey. Okay, alright, so we move to the next question. Okay, so we do a little revision for Bernoulli. Okay, so Bernoulli said the pressure of a moving liquid decreases as the speed of the fluid increases and vice versa. So mean if the speed decrease, the pressure decrease, the speed decrease, the pressure increase. If the speed increase, the pressure decrease. Okay. Alright, and then this is the activity to show the Bernoulli, right? So let's say there's a paper here, right? And I blow it, okay, on the top of it. So this one, the velocity will be high, right? The velocity will be high, but the pressure will be low. So at the bottom here, so atmospheric pressure is high, so it will push the paper upward. Okay, and for activity 2, right, so let's say I have a straw here and I blow the straw, okay, between these two ping pong balls. So here the velocity will be high, okay. Oh, sorry. I didn't notice the time. Alright. Sorry. Okay, sorry. Thank you, Junkang. Alright, I forgot. I didn't see the time, right? So we continue this next week, alright, on Monday. Okay, on Friday. On Monday, okay, we continue with paper 2. Okay, I will give you another handout. So that one for Monday we do another revision for our trial paper. Okay. So thank you, class. Sorry.